Welcome to Season 10 of the Prosthetics and Orthotics podcast. This is where we chat with experts in the field, patients who use these devices, physical therapists, and the vendors who make it all happen. Our goal? To share stories, tips, and insights that ultimately help our patients get the best possible outcomes. Tune in and join the conversation. We are thrilled you are here and hope it is the highlight of your day.
Hello, everyone. My name is Joris Peels, and this is another edition of the Prosthetics and Orthotics podcast with Brent Wright. How you doing, Brent?
Hey, Joris. I'm doing well. I'm super excited about today's guest. But before we get there, I will tell you, sometimes I wish I would have taken your advice and be like, Brent, why are you buying machines?
Dude, I tried to talk you out of it, man. You were like so gung-ho.
Sometimes, man, as knucklehead me, we've been trying to get the SLS stuff up and going, and that stuff is wild, man. There is so many parameters that you don't even realize when it comes to the powder bed fusion stuff. And I think that's one of the interesting things. You have the SLS snobs that are like, hey, I've got all the parameters, I can tune all these knobs. And then you've got the HP guys that are like, hey, I just have to throw my print in and it just comes out. And, the powder handling is done for you and all that. It's definitely been an interesting journey. I think it's going to be worth it. Some of the parts that we're getting off of it are amazing, but it's a journey nonetheless. And it's a journey that, you definitely want to talk to somebody that's gone before you if you're considering a machine, and that's any machine, FDM, SLS, multi-jet fusion, whatever it is, and have the person say, hey, give me the good, bad, and ugly, because going in with your eyes wide open, I think is important, because not only are you going to have money involved, but it's time, energy, and that sort of thing, and so. All that to say, I'm not opposed to having an SLS machine in. I'm just saying it's a lot of work. I think it's going to be worth it, and we more than likely are not interested in running a fleet of these, and we'll be contract manufacturing most of this stuff. But I think for us, having it internal is a good thing, because we know what we want, and then also so we can do quick turn parts and that sort of thing. Go ahead, let me have it.
No. I think one thing. So. Well, one thing I think you're being very realistic, I think. But I think one thing I think we need to know is that you're also using quite a very niche material. You're one of the only people in the world running this PK material. So, it would be a little bit different if you're doing like Arkema or Volnik PA12, you know what I mean? Doing a lot of things that a lot of other people are doing. So I think you are kind of putting, it's not just SLS that's hard, but you're putting yourself out there by being the only shop in the world that runs this PK black material, which I think is going to give you a distinct advantage, but also could be making it, there's less of a community around there and less of a bunch of people that know everything or have made those mistakes before you. So I think that's also a difficult thing, right?
Well, and I think that's a good point, Joris. And I mean, I'm seriously, I'd love to hear your feedback. Like this idea of the community, stuff that's known, that sort of thing is, I mean, I know there's value to that, but, on the flip side of that is we've just seen the performance of the PK5000 for powder bed fusion so amazing and excel all the characteristics of the normal stuff, the PA11, PA12, specifically for prosthetics. It exceeds it. It's not that PA11 and 12 can't be used for the prostheses. It's now that we've seen this, it's like, can we really go back? And so that's where we're at.
See, that's why. That's good. So persevere is, I think, my advice. And I think, you knew it would be hard, and it is going to be hard, but I think at one point it'll stabilize a little bit more, and it'll become much more, and you'll just be the experts at this stuff. So I think that's a distinct advantage for you guys.
Hey, all. Before we get to our guest, I wanted to introduce our sponsor for this episode, and that sponsor is Structure. You can find them at structure.io. And one of the reasons why I love having them as a sponsor is we believe scanning is foundational and can be done with excellence at a budget that you can afford. And so whether you use just their software or an attachment like the Structure Sensor 3 to attach to your iOS device, it is a great option to get that foundational scan. And sometimes people will ask, hey, why would you do something separate than, say, just the phone scanner? And the reality is there's a lot of reasons for it, but the main reason is that the iOS software or firmware changes quite frequently. And with that, so does the scanning parameters. And this is why it's so important to have an independent device that goes to your iOS device that is calibrated specifically for what we do. So I encourage you to go out, check them out, structure.io, check out their Structure Sensor 3 and a myriad of apps that go along with that. And let's pick up with Joris.
Who's on the show today, Mom?
Well, I tried to surprise you, but boy, that didn't work. So today we have industry veteran, I would say, Ruud Rouleaux. I've actually known Ruud for a long time. We've never met in person, but we text every now and then, and just a big fan of what he does. One of the things, and we talk about this a lot, he is the one that started ColorFabb back in the day, and then created this foaming material called VarioShore, which works very well, not only for foot orthoses, but then flexible interfaces and that sort of thing. And so depending on how much heat you put in, your settings, you can control the overall density. So like for, say, a 1 kilogram spool, and I don't think they sell them as 1 kilogram spools, but let's just, for instance, we use a 50%, man, the name is escaping me, but essentially you're getting 2 for 1. So you get the same amount of volume, but because it's foaming, you get more out of it. And then you get this very interesting material that's very lightweight, cushiony, and patients love it. And get this, and Ruud will appreciate this. We have patients that we've put into like multi-jet fusion with all our fancy lattice stuff. And then we've also put them into the ColorFabb flexible inner, and they're like, we like that stuff better. And so in some ways, it's, sometimes like I know that creating that formulation wasn't a simple thing, but, FDM compared to some of the stuff that we have to go through with the powder bed is I would say less complex, but to be able to get the results with FDM for prosthetics is really exciting. And it's really exciting for something that you and I have a heart for, and that's the developing world as well, in creating access this way. So I'm excited about diving into some of the history. He's right in the middle of it, of not only having this company, ColorFabb, but then talking about some sustainable materials. And so I'll be really curious kind of where we jump off.
Cool, man. So, hey, Ruud, welcome to the show.
Hey guys, hey Joris, hey Brent, nice to be here. Thank you for inviting me. It's quite an honor, and thank you for the kind words and the introduction.
So Ruud, how did you get started with 3D printing? Did you just see the technology come up in the Netherlands? Did you decide to jump in, or?
It's a little bit more complicated than that. So I have a background in plastics engineering. Essentially, when I came out of university, I started working with Pro Engineer. That's a CAD package. I think it's called different right now. But part of my job was also to create prototypes, typically going to materialize to get an SLS or SLA model. Back in the days, I'm talking about early 2001. So that was actually my first encounter with 3D prototyping. And I loved it, but it was quite unaffordable at that time. Not even desktop, of course. So following that career in mold making, I got kind of involved in colors and compounding and new materials, etc. As a sales engineer, as a sales rep selling colors, master batch. And that's how I first got involved with PLA, 2004. The early days of NatureWorks, making colors, making formulations, and it was the kind of new sustainable material out there. So roughly 20 years back, if I recall, was when NatureWorks started making traction in this market. Not knowing, of course, what may have to come, what was laying ahead. So after 6 years of working with PLA, 3D printing kind of became a big thing out of the RepRap era, of course, recalling the early days of making printers together with Ultimaker, etc. And suddenly somebody popped the question, can you make filament out of PLA? Well, I said, of course, I know a thing or two about PLA with my background in colors, so why not? So we're talking about 2010 here, when the first ideas were born, and about 1 year later, there was the soft launch, I have to say, of ColorFabb, acquiring a line and making first filaments. So that's about 50 years back right now.
And the funny thing is that in the Netherlands around the same time, I think also thanks to Eric, one of the founders of Ultimakers on TV, a lot of critical mass erupting around this development in the Netherlands with Ultimaker and stuff like this. A bunch of people, like 4 or 5 companies started doing this and were ultimately quite successful to varying degrees. And you guys have been very successful over the years. Why have you been successful? Well, I mean, what's the key to your success in this, a market that no one really knew what they were doing, right? In the beginning, it was like, you didn't know what you could sell it for. You didn't know who was buying. You didn't know what they were making it for. You didn't know if they wanted like 100 colors or they wanted it to be cheap. And then all of a sudden you guys are successful. So what do you think are the key things to your success?
Yeah, great question. So going back again 15 years, I think the technology point and the value promise at that time were actually sparking a lot of interest in this. Well, let's say in this region, in the Netherlands. Of course, you had to start up Ultimaker here. And that was around the time when I bought my first printer. It was a kit, a wooden kit, plywood. You had to mount it yourself and get it to run, which was very difficult for a let's say, mechatronics engineer like I am. So I have a materials background and I wanted to get this thing to run with the perception, with the idea, this is going to change the world radically, right? So in the future, it's just a click on the button and this thing will print as anything. So that was my expectation. Boy, was I wrong. So I got this printer back to Ultimaker and asked the question, let's get this to work, okay? So I learned a thing or two. And then I actually had the vision, okay, at one point in time, this value promise might get there. So we need to be innovative. How can we functionalize, let's say, our material sciences to deliver our part of this value promise? And that's exactly what ColorFabb is about, delivering functional materials, specific colors in order to enable, let's say, 3D printing as a production method. So this is our core principle. Those are our core company values. So being, let's say, passionate about 3D printing, being curious about what kind of functionality are we going to deliver, and be courageous, keep going. I mean, failures are, let's say, stepping stones to new successes. So this intrinsic drive to develop new functional materials, that's our key success factor.
And then I think so one of the most amazing things I think you guys ever did is this color on demand stuff, which I know you can do it, but I still don't understand how economically speaking you can do it. But that to me also is a secret, because I don't think I've worked for film and extrusion companies and materials makers and stuff. And the idea of just being able to, in a really, like from one spool or a few spools, being able to make a custom color.
Yeah,
it's an operational nightmare. You have to purge the machine. You have to, you track this thing. You have to put it somewhere, make a label, make all that work. So to me, that is also a secret where I'm thinking that not a lot of other companies could have done that. And the fact that you guys have been doing this for so long now, it kind of means there is like an operational excellence thing going on in the background there, right?
Kind of. So the idea is, of course, not new. It's like going into your hardware store or your paint shop. You select a color and the color mixer makes it on site. Our idea is not that different. So yeah, having a colors background, of course, I have been in many color compounding and color master batch manufacturing facilities. You pick up some ideas here and there, right? So back in 2016, we got a grant that allowed us to develop the building blocks that we need for PLA color on demand. It's in our name, color and digital fabrication. That was the original idea. In the future, it's going to happen. So custom colors in any volume is part of a value promise. So the idea materialized in 2016 and has been, let's say, developed over and over again over the last 8 years. And now we have reached a point where we're becoming not very efficient. This means from an initial start point to the demand we're seeing right now needs a scale up, needs an investment, etc. So we're turning this idea around again to follow up with the market demand. But the original concept of, let's say, developing building blocks that we can mix on site to make as less as 750 grams as your MOQ, it's still happening every day. And it's growing every day. So yeah, I would say this is one of the core technologies that allowed ColorFabb to be where we are right now.
Yeah, because it was a bit crazy that at one point, like I think it was like 2 or like 3 out of the top 5 filament makers in the world were in the Netherlands, and it just doesn't make any sense, right? Because we don't have that much of a plastics industry. We have a little bit, but compared to the world, it's like it should have been somewhere else, right? And it was really, really kind of crazy. And another thing, I think when really people started to really notice you guys. Well, first it was with I think maybe that's first. I don't remember, but it was all these brass-filled materials and stuff like that, right?
Yeah, that was a great time. I mean, we officially entered the market in 2013. I remember it well. It was the London 3D print show. The whole world was kind of new to us. So I think like 2 or 3 or 4 brands entering the filament space. So this is, when was that? October 2013-ish. I'm not sure. Anyway, there we are with 2 wooden Ultimakers on this 3D printing event. And we brought a first trial from a wood-filled material. So we literally launched that as wood fill, but those were the first 3 or 4 spools that we're printing there. So it's a material composite. It's a PLA with dust in there. But the experience was quite different. So people actually stopping at a booth asking, hey, I smell wood burning here. What's going on? Are you guys printing with wood? And that idea sparked a whole range of innovations like material composites, not only with wood, but with different fillers, with cork. We had bamboo. And then one of our suppliers said, hey, you got to try this with bronze. We were making bronze composites, nylon bronze composites for making bearings, dry bearings. I said, okay, so if we switch the nylon component to PLA, would that be possible? Yeah, let's try that. Together with some suppliers, we checked if we could print PLA with a concentration of bronze particles in there. So if you print this, you guys, I'm sure you guys have seen it. It has like a dull brownish finish, and it's non-reflective because really the bronze particles, they are perfect round spheres, so they are not reflecting any light. So you have to polish it. And that's where the fun factor comes in. So the bronze fill actually added a new dimension to 3D printing because some post-processing is required. But ultimately, you can get the gloss back, and even the material can start to corrode, creating a patina. So this opened up a whole new range of possibilities in desktop 3D printing. And yeah, those are the innovations that actually are a lot of fun, but also create a high amount of value, of course, in 3D printing.
Speaking of the value side of things, I mean, I know you and I have talked about that, and in that, I think ColorFabb has really done a great thing about staying in the filaments that do provide value. So you've got your colors, and then you've got some of the foaming stuff. You have some of your exotic filaments, but can you share just a little bit about how, like, why that came to be, and then how that has shaped what you guys have become?
Yeah, sure. So you have to dive a little bit into the supply chain of typical plastics manufacturing. So we have raw material suppliers, additive suppliers, color suppliers, and we have compounders that make specific formulations that are used in, for example, injection molding, extrusion, sheet, packaging, you name it. There's a whole industry out there. So based on what already has been done, there is an enormous range of possible material combinations that might be suitable for desktop 3D printing in filament shape. So it's our fun factor to explore what's out there and how can we bring this to good use in desktop 3D printing. I mean, PLA is obvious. PLA is a very versatile material with its pros and with its cons, but looking at different materials as well, how can we create value? That's always the key question. So this is the space where we operate. We're not cheap. We have a lot of overhead, so we have to deliver sufficient functionality and added value in order to grow sustainably. This led to a really good cooperation in 2015 with the Eastman Chemical Company. You might recall that. We developed some copolyesters.
The engine.
That's engine, that's ColorFabb HT, which is based on Eastman Triton technology. So that was a great partnership because we saw next to PLA lots of new materials that were amorphous, that have higher temperature resistance, good printability, etc. So Eastman kind of paved the way for us into the functional space. And they have been very cooperative, and this also led to some carbon fiber composites or CF20 materials in the high performance strength materials. And from there, we actually explored a lot of combinations. And one of the, let's say, biggest successes starting from 2016 has indeed been the lightweight materials, where we use a technology that allows, let's say, the material to foam, to expand right after exiting the nozzle. And this, again, added a new dimension into the FDM, FFF 3D printing space, that you can, let's say, reduce your density, reduce your material usage, and completely change the outlook, the perception, surface, appearance, haptics, etc. And I mean, the innovation dates back to 2016, but is still growing. So imagine, let's say, the kind of impact that had. And we're really proud of that, of course, in the 3D printing space. So this is an original ColorFabb innovation that's going very strong today.
Yeah, and the exciting thing about this is because like nozzles are actually kind of dumb, right? As in the time to warm them up and heat them and cool them down, it's actually quite considerable, and there's residual heat, and it's actually very difficult to go, from 218 to 220 in a kind of organized way. So if nozzles would get smarter, right? And a lot of people have been looking at doing this. If nozzles get much more responsive, you could do even more with this kind of material, right?
Yeah, that's correct, Joris. So we're seeing some very exciting innovations coming our way, coming into FFF next year. I mean, we have already talked about induction nozzles. We've seen one brand, we've seen two brands doing this. I think it's going to be a standard feature on a lot of desktop 3D printers the coming years, because it allows your material performance to change dramatically in terms of control. And this also brings us, let's say, to a different topic in terms of data. If your printer can control a lot of, let's say, data very accurately in terms of G-code, changing speed, output flow, temperature, etc. Imagine where this will bring FDM 3D printing in the years coming in terms of functionality and appearance of final parts. I believe this is truly exciting, and this stuff is happening right now.
Yeah, I totally agree. I think if we look at something like flow control, for example, where you can do much more in determining flow at a certain point and linking that to certain geometry. And if we just look at what some of the slicers are doing, what Bamboo's doing and stuff like that, on just that control of that nozzle and the control of your stepper motor at a certain speed, at a certain point, it's of course super exciting to imagine, much more digital control over your output and a much more coherent kind of extrusion setup than we have now. And then, you throw in something like induction nozzles or something like that, which is a little more difficult than it seems to do in real life, of course. But you throw in something like that, and you can have like much more it's actually much more of a digital process rather than, kind of like, squeezing out a toothpaste tube without really understanding what pressure happens and what wall slip effects and what fluidity and all that. You could really make it a much, much more controlled process, much more discrete process.
Absolutely. And I think we're just scratching the surface here, guys. I mean, there are so many things heading away, like AI and different user interfaces, etc. So I have seen brands tinkering around and playing with end topology, end top, software package, field modeling. It's super interesting what this will bring to the FDM space. I'm using it myself. I have one license. It takes a lot of time, but let's say latticing, also in FDM, surface texturing, it's just off the scale, next level cool to add certain surface textures also to your, for example, VarioShore TPU product. We have seen this in shoes. We have seen this in orthotics. I'm a big cyclist fan myself. We have, let's say, been engaged in some new developments with cycling accessories like bike ribbon. We are working on saddles. We have a guy from Belgium working on top tube bags, one piece, shoe covers, whatever. So in sports and leisure is also, let's say, there is a big opportunity for FDM 3D printing in combination with functional materials and, let's say, the enhanced capacity of future 3D printers and software and G-code. If you combine all these, we're going to see fantastic products.
Yeah, and I think it's great that you point out like textures, because I think there's such huge. You mentioned haptics before. You can make something much more expensive feeling, or much more interesting, or work much better. Think about a tool and just wearing that surface. You want to put certain cues or certain things to make that tool be easier to use or better to use in some way. Wick away sweat. There's so much you can do with textures. And I think one other thing, if we're looking at this thing, is like on the implicit modeling, plus better, more control over your G code generally, plus more control over the machines, plus input shaping and more advanced input shaping, I guess, that takes into account a lot of like the kinematics, a lot of the stuff on the machine, plus more understanding what goes on the nozzle, right? And then better heating and better maybe pressure control, I think, is the one thing we're really missing, that a more accurate pressure control on that, and sensors knowing these kind of things. If you look at all that together, I think, the one of the things that really is missing as well, if you're looking at this functional shapes and functional materials making functional end-use parts, is kind of like that if we look at infill's kind of been like, it's this dumb thing we come up with at one point, and it happens to be a honeycomb because that seems really efficient, But there should just be really many more abilities to make infill a certain width, a certain height, a certain shape to really get really, really specific properties out of it.
Yeah, I can give you a nice example there. I was recently in Spain, in Valencia. I know you know quite well there. I was talking to a company called Neofoam. Nicola Uden, he lives there. He is also active in the orthotic space. He discussed a workflow he has been working on modifying G code in order to, let's say, assign specific densities in infill. To me, it was next level. It took me a while to get it, how he did it, but it's quite innovative. Post-processing G code, adding certain scripts there, also dramatically can change the level of, let's say, geometries, densities, variations in one part. So it's all data-driven, guys. This is definitely going to happen.
Yeah, super cool. And so talk us a little bit specifically for orthotics and stuff like that. I think, the big thing Brent mentioned already is VarioShore there, but you've also got specific like VarioShore for prosthetics, right? With like kind of like colors and stuff like that.
Yeah, that's something that was already done during the early days of VarioShore. So we started this development in early 2018. And one of the first questions we got, hey, we would like to see a portfolio of different skin type colors. And one of the cool features was, so if you look at the filament, which is unfoamed, it can be a very brilliant color if the material starts to foam. Depending on your temperature that you set, you get different skin tones. So if you, I don't know the exact name, if you print a temperature tower, you can basically mimic already a lot of skin tones. So that was the idea behind that. So we start up with 4 or 5 basic skin tone colors from, let's say, we call it medium pink to dark brown. And I think between there, you can actually set yourself by defining the temperatures. Imagine how a product can benefit from that by let's say, arranging or let's say tweaking the best possible color there. And I mean, we only did 5 colors. In the future, I guess we can, let's say, pinpoint even better according to a reference. So that's also a step that we're investing in 2025 to do more color matching in VarioShore.
Yeah, I love this so much because it is really cool, and I think you can imagine so many people like who've not had a device, the color that has been close to their skin tone or something like that, and that would be really amazing if you guys could get like most people's skin tones, or even like everybody or nearly everybody. That would be really cool.
Okay, good to hear. We can do that.
Okay, and then another thing, I think if we're looking at these materials, I mean, I think the foaming type products are kind of really exciting. Then you've also got lightweight products. Are there other ones you would consider especially exciting for the orthotics and prosthetics world, let's say?
Yeah, I mean, maybe a side note here. I'm also involved in a company called Poto Printer. They produce a belt printer software material combination, which is also based on VarioShore. There we have recognized some different opportunities. For example, supplements and hard shells. Okay. So I guess in the US market, you will see more hard shells materials. So also there, we are looking into types of VarioShore that have a harder starting geometry to start from. So currently our starting durometer is Shore aimed for, let's say, those hard chest material. We see also opportunity to make, let's say, something in the Shore D higher range or combined with certain fillers, mineral fillers or fiber fillers, etc. So combining that functionality is something that we're looking at. And also, of course, like we showed on the format, the lower durometer, so below Shore 80, this is typically where we would enter the shoe domain, not only focusing on shoes, but also on medical flip-flops or medical slippers, etc. That's also happening with some of our customers right now.
And are you, like, I think of the whole prosthetics thing, I mean, are you the most bullish about like orthotics, insoles, that kind of thing, or just the whole business of doing this?
A good question. So circling back to Brent, I was intrigued by his work on let's say liners in sockets. So that's a space that's definitely developing. Our personal experience over the last 2 years is that the brand name VarioShore has kind of become a benchmark in the insoles manufacturing industry, replacing EVA foam, replacing milling, etc. So we see the biggest momentum there, but not necessarily only insoles. So I regret to say I don't have the necessary background there to make all those claims, but we see in the whole branch of orthotics in general, we see a lot of innovations happening based on VarioShore. Once again, the biggest is still in insoles.
Yeah. And how about just generally more trends? I mean, do you have any idea what industries are growing the fastest for you, for example?
Yeah, sure. So this year, the collaboration with Zellerfeld has, of course, triggered a lot of exposure, sneakers, shoes, etc. So there is lots of innovation going on there, in combination, of course, what we already said with post-processing, implicit modeling, and texturing, etc. So this is triggering the shoe industry. Well, some other fields, like I mentioned, perhaps running, so let's say specific orthotics or even midsoles, etc. We see some activities there as well.
So I think one of the things that's interesting, and you could touch on it a little bit, and one of the reasons why FDM just has, to me, it's been a little bit slow on the uptake for, especially on the prosthetic side or even on the shoe side of things. But with the advent of, say, like the entomology or people that are super proficient in grasshopper or rhino grasshopper workflow, is this idea of textures and being able to hide lines, seams, and also the ability to go non-planar. And I think that's why a lot of this, and then you obviously have bamboo and some of the other ones that have come into play. But so now you start being able to create these very eye-catching, layerless looking products for the masses. And I think this is it's a massive deal moving forward. And I think it's neat. It's definitely harder for the designer to get all that stuff right. But man, as we keep on going, FDM is really a cost-effective way, especially if the materials are right, to move forward.
Yeah, exactly. Adding to that, Brent, what also has contributed to this growth is, we saw the first momentum. This market catching up, taking up speed. When was that? Like 2 years ago? So we got a lot of feedback from the market. Okay, we need to improve here. Can you do that? Get this sorted out, etc. So one of the big investments we did last year and also this year is to take care of all the necessary compliances. For example, if some people require skin contact, can it be done? Right, we assume so, but let's prove it. So we spent a reasonable amount of cash, let's say, assigning certain research to companies like UL, Intertech, and in Germany, PFI, who are established names in assessing the research for skin contacts. I believe there's an ISO standard, 10993, which addresses all those questions. I think there are like 10 or 15 amendments there. So we took care of most of those to test the material. Is the material fit for orthotics? Can you use it directly on skin? Any objections? So the whole homework package was researched. And recently, I think it was like 2 or 3 months back, we give out this declaration of compliance that we have passed all those tests. So I think this also contributes, let's say, not only on the hardware and software side, so also on the material side. You want to have all the critical success factors in place to fully go out in this value stream.
Yeah, I think that's a very interesting thing. And if you're looking at, well, have you guys looked at other technologies, or is it FDM only FDM for you guys? Because it would have been tempting for you to make something else, right?
Yeah, it is. So just mentioned the early Ultimaker days. We were like on Kickstarter every day scouting for new types of machines. So we got one of the early SLA machines, only to find out that that the chemistry in resins and photo initiators was not very skin friendly. So we sold that machine again. And I think for some years ago, and we're just discussing SLS with Brand, we had one of the first, what was that, Sintratec machine, playing around with powder. Eastman was also working on that with different polyesters. At one point, we decided to abandon that as well because we were making tests in a factory and had powder flying around here, interfering with a filament manufacturing process. So that was a big no-go for us. So they said, okay, let's stick to our trade. So yes, we did play around a little bit with different techniques, different polymers, but ultimately we decided to stick to FM.
Well, congratulations on that. I wish you would have told me that a while ago. Talking about powder flying everywhere.
You like your vacuum cleaner? Do you have a nice vacuum cleaner? I get you one for Christmas. I get you a really nice vacuum cleaner for Christmas. That's the one thing that every SLS guy wants. A really amazing Swedish vacuum cleaner.
Well, Brand, I have to give it to you. I was reading your LinkedIn post. You were like married like 20 plus years to your wife. I don't recall the exact number, but you mentioned that besides your wife rolling with her eyes, if you're thinking or talking about this new 3D printer, hey man, I know that feeling exactly. So I saw you writing about an SLS machine. Okay. And I thought she's in for a surprise. Anyway.
And we're seeing a lot of like attention right now from people trying to really do print farms for manufacturing. Part of that is orthotics, right? But it also goes much broader than that, where people are really doing bigger manufacturing installations with hundreds of printers. Do you see a lot of traction there as well from your point of view?
Yeah, definitely. Of course, you already mentioned it when Bamboo entered the market. I mean, SMEs, small, medium enterprises, can start a business with relatively low investment. And the amortization time in this space using that kind of hardware is relatively fast. So it's easy to just purchase a couple of printers and get going. If you're knowledgeable in 3D, and you know how to design your product, it's fairly easy to start manufacturing. So the answer is yes. We're seeing a lot of activity in the space. It's not just only people with one or two printers. So it's easy to find companies right now who already are running somewhere between 10 to 20 plus printers. So if we consider this a print farm, I would say yes.
So on the prosthetic side of things, we talk a lot about the flexibles that have done very well, like the VarioShore and things of that nature. And now with some of the high flow stuff too, you're starting to not have to worry as much about layer adhesion, specifically in the Z, because you've got so much thermal mass. What are your thoughts on materials and such that will end up with a very strong final product for prosthesis? I know that there are some out there, and I still think that just because of the history of FDM, it's going to be hard to shake that fear of Z layer adhesion. But what are we really up against? Like, from your engineering background and what you know about some of the prosthetic sockets and the forces, what are we up against, and where is there opportunity in FDM, and where is there, it makes it a little bit more difficult?
Okay, that's a tough one. So focusing on our own material portfolio. So we run PLA, which is a polyester. We run copolyesters from Eastman. We have some nylons. We have a lot of composites, TPU, etc. There are plenty of opportunities that have not been explored. So multi-material, if you can combine materials crisscross in this material family in one print, you can make off the scale properties, right? So combining those real time, that's an opportunity. We also are looking into various copolymers. For example, in PLA, you can easily tweak melting temperatures, impact toughness, etc. Even your TG can be modified to function in a certain range. So you can use those to make, for example, this is kind of a wild thought. You can produce B component fibers, which is typically, if you look at the cross section, this is a core shell material. Imagine you use a very high tack PLA on your shell and you use a soft core, which might be a TPU or a soft PLA. You can achieve crazy layer adhesion, and the product would be more or less toughened because of the, let's say, the soft inner core. So if you combine those properties in let's call it cold core shell or shell core structures, they can give rise to complete new functionalities. And you can also regard that as a multi-material, let's say, combination. This is standard practice in textiles, by the way. So we believe this might also have a bright future in FDM 3D printing. It's a little bit more difficult to produce, but for the user, it will not make any difference. Just add a lot of more performance. So this allows also the way to combine, let's say, non-compatible materials in one print.
So it sounds like it's really not a material issue. It kind of comes down to what you're talking about with the manipulation of the G code, some mechanical stuff. Like, how do you actually get the material properties from the machine that you want? So it becomes more of a hardware solution. I mean, obviously there's materials, but it is a hardware solution along with some software.
Well, not quite, Brent. It always, well, my perspective, to put it in my perspective, I'm most of the time looking at those challenges from a material point of view, right? So what can we do to tweak the physical appearance of a filament, right? Can we add a thin shell that allows more performance, that allows, let's say, layer adhesion? So this is a possibility from a material perspective. If I look at it from a hardware perspective, I would say, hey guys, let's go for a heated chamber that goes up to, I don't know, 80 to 120 to allow nylon to get the best possible bond. Of course, that's a possibility. And also G-code wise, there are still a lot of things you can tweak. So if I look at this trinity, somewhere is a sweet spot that is just going to work perfect. I mentioned it before, we're not even scratching the surface of FDM of what's going to be possible. It's just a matter of adding the calculation capacity in the 3D printer. So what kind of processor is in there? What kind of data can the printer work with? So that's a continuous evolution. I think Moore's law is actually still happening in 3D printing. Every year we see enormous, let's say, advancements in all those combinations, so hardware, material, and software. That combination is going to get us the performance we ultimately are longing for.
Yeah, I love that perspective. That's great. And it's so good to, I mean, so I think that's one of the things that, and I'd love for you to speak on this too, how important it is to have, I mean, we would call it interdisciplinary, but, you have to sometimes, orthotics and prosthetics is our life. But like, if you were to come to, say, an orthotic and prosthetic show and you look around and you say, wow, I mean, there's some very cool things that are happening, but wow, you guys are kind of doing it the hard way as well. And so having that data going back and forth with the human capital, human subject matter experts, material, and then the side of the stuff that we're doing, whether, the interaction with the body, or if you're talking to somebody like the bike parts, like those people that are specialties, it really is, how do we all communicate, come together, and throw the best things on the table that we think may have a good chance at going?
Yeah, that's also a tough question for me. During daily life, I'm mostly involved right now with new material sustainable material innovation. So I'm working in the PHA space. So part of my time I engage with people from Proto Printer in the insole space. So part of that is also visiting trade shows. Right, I've been at the OTS in Cologne in Germany, and there's another show called OT World in Leipzig, and this is typically the mecca. So this is the place to be in orthotics to catch up with the industry, right? So one of the things I learned there, that what I consider to be a very conservative market, the German orthotic shoe market is accelerating dramatically. Being old-fashioned artisan shoemaker who really had the trade in their hands, they are very focused in digitalizing and catching up, let's say, 3D printing production methods for various new products. So talking to those generation that are actually willing to make the transition, that are intrinsically motivated to learn, let's say, digital manufacturing of their products. This is what truly inspires us. Okay, what do you guys want to achieve? Because one thing we've learned there, each orthotic shoemaker or prostheticist has his own signature product, their own way of working. And I think this is key to understanding what a certain individual wants to achieve or what vision they want to materialize. This is actually what drives us to actually make the material that can all make that happen. So it's not a general case. Each customer, each individual has its own needs to be successful in this industry. That's what I've learned so far.
I think so. Just, and this is a super loaded question, but it's more you could answer or not answer, I guess. But like when you take a look, say, around the OT world, and you mention, hey, it's your signature, way or what have you, and that is important. But we always go back to some of the stuff like what we were talking about earlier, where you've got end topology and some of the AI stuff coming down the pike and that sort of thing. Would you say that while the signature aspect is that truly necessary to move forward, or can that be put into like the cog of data and experience to make everything move forward? Not necessarily like a standard, but in that sort of sense, does that signature matter as much as what we think it is, as far as from a clinical standpoint?
Well, we're based in Holland. I think we have like 1,200 podiatrists here. As far as I have been told, most of them, of course, can work with certain templates, for sure. And some of them have their own ideas and background or even own specialisms. Okay, I specialize in this kind of treatment or that kind of disease. And that's all fair. So holistically, I would say if you look at some other industries like dental or something like hearing aids, especially hearing aids, this whole industry has now converted to digital manufacturing. So this is going to happen also for orthotics. I mean, it's eat or be eaten. Some of the players are moving along more, let's say, faster and efficiently than, let's say, perhaps smaller offices. So I think, okay, and I have to be careful what I say here, but some of these signature processes ultimately might be filtered out because of new standards entering this market space. It's evolution.
I like it. I mean, so I think in all that, and I would say, like, just from my experience in the digital side of things, it's been very humbling, especially when you take a look at Joris and I just did a podcast with Josh Steer from Radii Devices, and they're doing, it's kind of a machine learning model, but they're doing like some really interesting connecting of scan inputs versus modification versus patient outputs. And what they're finding is that their model actually does pretty well, but then they're also finding that it's important to have a specialist involved, a prosthetist, orthotist. And so I think that there is a a combo or a trifecta where you have the patient, you have a software that's helping the clinician, and then the clinician has eyes on the patient and they have a good outcome. So I like, to your point, hey, we might be filtering out some of that stuff because we're evolving and the data is getting so loud that we can't not use it.
Yeah, and adding to that, I mean, over the course of the last couple of years, I've heard some and seen some wild ideas. And one podiatrist came to us. Yeah, I'm a little bit scared. I mean, the iPhone is getting so good at making pictures, also detailed topology of the bottom of my foot. Ultimately, if a podiatrist sees that picture, they can already, let's say, make a detailed analysis where to go or what to resolve. So if AI can do that automatically, I mean, wow, okay, then will this trade become obsolete? Question mark. I don't know. There was another company reaching out to us at one point, which is a brand I cannot not tell on the podcast, but it was a big shoe retailer, like with 1,000 stores throughout Europe. And the guy said, "Hey, I want to put every, let's say, potential customer on a scanner. I want to have data. And with this data, I don't know, I can give him a rebate or a discount on a shoe as long as we can use the data to follow up." So ultimately, it's going to be about data. How many, let's say, data can we process and make an analysis, or say, hey, you might benefit from this insole or that kind of shoe, or completely go custom. And that's an opportunity that Zellerfeld is leading us the way. They already can customize a certain model according to the geometry of the picture that you send them. Just, let's say, they allow you to take a picture on the upper side of your foot just by iPhone, and they can, let's say, use that data to fully customize your shoe. So that's going to be a possibility that might change the whole industry again. So complexity again, AI using customer data, fully customization.
That could be really, really exciting. A lot of consequences as well. Hey, Ruud, thank you so much for your time today. It's really wonderful talking to you.
Yeah, guys, thank you for having me once again. I think we can chat for a couple hours more, but anyway, I hope to catch you guys again soon, and keep up the great work, guys. Thank you.
Thank you. And yeah, thank you for being here as always. Again, Brent.
Yeah, this was great talking shop, and we ran the gamut, right? A little bit of history, a little bit of into the weeds, and so this was great. So thank you, Ruud, for sharing your experience and journey. I know our listeners will get a lot from it.
Thank you, guys. Appreciate it.
And thank you for listening to another episode of the Orthotics and Prosthetics podcast. Have a great day.
And that's another wrap of the Prosthetics and Orthotics podcast. A special thanks to Ruud for sharing his insight and experience, and a special thanks to Structure. Go check them out at structure.io. Check out their Structure Sensor 3. And until next time, we'll see you on the next episode.